Hi, I'm going to demonstrate the concept of a new kind of IDE to you, SketchCode. Now, the problem that SketchCode addresses is the time and the work it takes to iterate a web application. Whenever you've got a cool idea for some web-based service, it usually takes a lot of work in terms of developing, iterating, testing, and revising a program for the idea to develop, and finally you get what you want. Now, SketchCode tries to shorten that process and takes the sweat out of it. It relies on three basic principles to do that. First, instant feedback on your actions. Whenever you as a programmer make a change to the source code, the program, the effects of that change should be immediately visible to you. In that way you can make small changes, learn from them, and then iterate. Another thing that SketchCode does, it represents concepts directly. This means the editor displays diagrammatic and graphical visual representations for concepts that you're working with alongside plain text. If you're working with colors, like CSS colors for websites, instead of working with color codes, hex codes, you get real colors. If you're working with math, you get equations. Finally, SketchCode is not one large framework that provides features for all situations you can think of. Instead, it is a platform that is very easily extendable using HTML5. This means that as a SketchCode programmer, you have the ability to quickly and easily define context-specific editors for the problem that you are dealing with at the moment. This is a screen dump of the current proof of concept implementation of SketchCode. It runs inside a web browser. It's a HTML5 based application. On the right hand side you see a code panel that includes visual elements alongside plain text lines of code. On the left hand side you see code that is used to extend the functionality of SketchCode itself. In other words, it is extensibility for SketchCode in the form of a library. Now, let's give you some examples. The first thing is, I'm working with colors on a web page. In this screenshot you see on the right hand side a website running inside a web browser. I want to change the black background color of this main area. On the left hand side you see the code editor, you see SketchCode editor showing the CSS color codes for this website. But since I have extended SketchCode so it understands colors as a conceptual thing and not just ASCII text, look what happens when I move the mouse. Move it into the color code that defines the main area's color and it turns black. Furthermore, when I click on it, I get a color wheel, and when I choose a next color, click, it updates the color inside the running web page automatically. So what we have seen here is both that I'm working with colors at the conceptual level of a color and that I get immediate feedback. Now, it's important to note that modern IDEs can pass out color codes out of web source code and provide the same support. But this is not the point here. The point here is that SketchCode is extended by the programmer to deal with this specific concept. We see the benefits of this approach in the next example. Interaction. Interaction is the flow that the user has through an application and how the application reacts back to him. And this is something that is very difficult to represent concisely and directly, obviously in source code. So let's see how SketchCode tackles this. I'm going to show you a small clip from a menu on Vimeo that behaves inconsistently as I interact with it. You see here is I hover the Join button, the Login button, Explore has a submenu, Help has a submenu, and when I go back into Login, the submenu does not disappear. There's no submenu associated to login, When I come from Join and hover Login, there is no submenu, but when I come from Explore, the submenu stays. This is a bug. This is an inconsistent behavior in the interaction. Now, what's the SketchCode way of addressing this? On the left-hand side, you again see source code, and you see inlined a diagrammatic representation of the interaction. A common computer science concept to model interaction is a state machine. You see on the left-hand side of the diagram the plain state, which represents the menu when no submenu is shown. When I hover the Explore button, follow the arrow to the Explore shown, indicates that this puts the menu into Explore shown mode. What's also apparent from this representation is that when I am in Explore shown mode and the Explore submenu is visible, and I hover the Login button, the arrow goes from Explore shown back to Explore shown. So actually there is no state change back to plain there. Because this is shown at this high level, at the diagrammatic level, I can also edit it at this level. So if I move my mouse to the arrow that goes back to Explore shown, I can drag it to plain, and I have changed the interaction behavior of this application in this way. Notice how this isolates one aspect of the application, interaction, and I can edit it directly. I have a better representation, one that helps me visually to identify how things should be, and also one that allows me to come up with new scenarios for interaction quickly so I can explore them quickly with users. Thanks for watching.